we are going to take this function, which happens to be an absolute value function, and we are going to analyze it. So there's all these different terms. Some of them may be new. Some of them may be something you've seen in 8th and 9th grade, and we're going to apply these math terms by analyzing this function. So let's get started. When we talk about domain and range, we're describing the x values and the y values of the function. If that's something you don't know, please write that down. We're describing the x values and the y values. Now at this level of math, it's very important that you're precise in how you describe them. So we're going to learn about the difference between using parentheses and using brackets and what it means. We're also going to talk about function notation as we go through this. So when I look at the domain, what I'm asking myself is if I analyze this graph from left to right, I want to know, are there any breaks in the graph, or is it continuous? This arrow means for this particular function that as it moves to the right, it will continue to go up, and as it moves to the left, it will continue to go up. And so I'm going to use a piece of paper, and we'll see if that helps you. So I'm always going to go from left to right here as I work through the domain. So as I move from the left, I can see the function, I can see the function. There are no breaks. Yes, it's going down and now it's going up, but there's no breaks in the graph. So in 8th and 9th grade, you may have learned to write the words all real numbers. At this level of math, we use the following notation. This means I can go to the far right, far left, all the way to the far right. There's no breaks. The entire way, I will find pieces of this function. When I look on the x-axis and I go straight up, I will always be able to see pieces of the function. So every x value is going to correspond to a particular y value throughout this entire function. There's no breaks. So you should also do the same by writing this down. Now let's go to the range. The range does the same concept, but instead of going from left to right, which is negative x's to positive x's, we're going to work from negative y's to positive y's. Now, this is a little different. Do you see as I'm moving up, I see no part of the function? There's no part of the function. The first time I see any part of the function, I'm going to stop, and that is right here. Now, I know that your particular piece of paper, when it was copied, was not very dark, so if you could do me a favor, I'd like you to make these little lines here so you can see where this dot occurs. So the first y value that I actually see occurs at positive 3. And there's actually a y value there. It's not an open circle. So the range starts at 3, and as I continue to move upward, I will continuously see y values all the way up, right? There's no limit how high it can go. So 3 to positive infinity is going to describe the range. Here is decrease, and here's constant. These are just my own abbreviations. So increase means from left to right, it's going up. Decrease is from left to right, it's going down. Constant means it's going to be flat from left to right. When we describe parts of the graph that are increasing, decreasing, or constant, we will always, always, always use parentheses. Every single time we will use parentheses in order to describe them. Never brackets. Brackets would be the box-like ends. We always use parentheses, and I'm going to explain why in just a little bit. Next is we always use x values to describe where is it increasing, where is it decreasing, and where is it constant. Now, some people will just memorize, I got to use parentheses, and other people will have a better time remembering that if they have a deeper understanding. So let me explain the deeper understanding. If this was you and you were running, you'd be like, from left to right, I'm going downhill, I'm running downhill. But when you got to this point, you wouldn't say you're running downhill, you wouldn't say you're running uphill, you'd say you're resting, right? You take a short rest, and now you're running uphill. So coming from the far left all the way to the x value of positive 2, you're going downhill. But at 2, you can't say you're going downhill, you can't say you're going uphill, you're just resting. So let's come down here, increasing. I know that I'm going to use parentheses, so the very first thing I'm going to do is put parentheses down. The next thing I'm going to do is I want to identify where is it increasing. So remember, increasing is going up from left to right, and the only place is right here. So I'm going to darken this in just so you have a better idea. This part is the increasing part. Maybe I'll even cover this up. So after you leave an x value of 2, it increases. At 2, you're not increasing, you're resting. After it leaves 2. And for that reason, we're going to put 2 with a parenthesis, because at 2, you're not increasing, you're only resting. And as you move to the right, you're increasing. Increasing, decreasing, and constant, you're describing a rate of change of y values, okay? Let's talk about decreasing. From left to right here, from left to right, you're going down. Left to right, you're going down, so this is the decreasing part. Now, in terms of x values, it comes from the far left. X values, it comes from the far left, and we describe the very, very far left as negative infinity, and it'll continue to go down until it gets to an x value of positive 2. At positive 2, you're resting. You're not decreasing. That's why we put a parenthesis. Increasing, decreasing, and constant, which we'll work with later on, always use parentheses. End behavior is probably a new thing for you, so I would like you to go back to your blank piece of paper, and I'd like you to write down the general format for this. This is your general format. I put the words down to the left and to the right just so you get used to what this means. I'm going to press pause, let you finish writing that down, and then we'll apply it. I come down here, I'm going to put that general format in. So y, this box tells me I need to fill that in. And x, and x. End behavior says always go out to the far ends of the x-axis. Sometimes students are like, do you mean y or x? Always x. So we're going to go to the far ends of the x-axis, and we're going to describe what's happening. And we always have 3 options. So these boxes have 3 options. One option is it's heading upward. It's heading upward, and we use the symbol plus infinity to say it's heading upward. Or it's heading downward, and we use the symbol negative infinity to say going downward. Or it may be flat. It may be constant or flat. And when it's flat, we're going to say what y value is it flat at. And you'll see that with upcoming examples. Okay. Miss Galindo, you have been so kind to volunteer for me. Okay, you ready? Let's start here. This means go on the x-axis to the very far left, and I want everybody to make a nice oval-shaped circle on the very far left. Everybody's going to do that. Now, Aubrey's going to describe what's happening. Aubrey's going to describe what's happening. Aubrey, watch my writing utensil. As I enter into that oval, because we're describing the end behavior on the far left. As I enter into the oval, what thing is happening? Is this line right here, the function, is it heading upward, downward, or is it staying flat? It is headed upward. So it'd be natural to write the word upward here, but look in your notes. What symbol do we use for upward? A plus infinity. Plus infinity. Okay, let's go to the next one. Raphael, I'm going to call on you next. So I want everybody to come over here and make a really big circle, an oval circle, on the far right-hand side. So I went to the very end of the right-hand side. End behavior will always be for x's on the very right-hand side. Now, Raphael, as I go into that oval, because it's the end, as I go into the oval, is my function headed upward, downward, or is it saying flat at one value? Upward. So I come over here, and instead of writing the word upwards, I use the symbol plus infinity. Now, this particular function, it has no x-intercept because it never crosses the x-axis. What you should not do is put a 0, because if you simply put a 0, it means that the x-intercept is 0. So you have two options. You can write the word does not exist, or maybe you like to use this new math symbol that has two curly brackets with nothing inside. This means there is nothing. There's no answer. There's nothing. Does not exist, or you can put these curly brackets with nothing inside. Let's locate the y-intercept. The y-intercept is where does the function cross the y-axis, and it occurs at positive 5. Writing it as an ordered pair is 0, 5. Now, when you learned about quadratic formulas, you learned about parabolas, or these U-shapes that open up, or the U-shapes that open down. Your leading coefficient, if you're provided an equation, will give you a hint on whether you can predict that your shape opens up or opens down for quadratic formulas. The same thing can be said about this absolute value. Now, I worked through this with my previous class, and I reviewed how we came up with this equation. You don't have to write this down, but this is the equation of this particular function. And I can see that the leading coefficient is positive. You don't have to come up with this. That's a review from last week. But I knew that the leading coefficient would be positive because my shape opened upwards. So is the leading coefficient positive? Yes. Why? Because my V shape opens upward. Let's look at our next example, which is very similar to the previous example. And let's start with the domain. So remember, this arrow means it's going to continuously go down and to the left and down and to the right. It doesn't stop. This arrow means continuously down to the left and down to the right for this particular function. So as I look here from left to right, remember it extends the entire time as I go left to right. There would be no breaks in the graph because it's going to continue. If you have a hard time seeing this, it's going to be continuous like this. So the entire way from left to right, there are no breaks. So it's all real numbers, and we represent that in the correct notation as negative infinity to positive. Notice I'm using parentheses, not brackets. The range, just like I looked at the domain and I went from negative x's to positive, the range is going to go from negative y's to positive. So the range, we start down here. These arrows again mean that there's no limit how low it goes. Well, if there's no limit how low it goes, I write negative infinity. And now I'm going to keep moving upwards until the function stops. And maybe it's easier to see that if I have a blank piece of paper. So I'm going to keep moving up here, keep moving up. I'm going to zoom in case you see it better and back here. Keep moving up. And at what y value is the last number I see? It occurs at, is it at 1? Negative 1. Good. So we're going to go all the way up to negative 1, and it actually is a closed dot. I need to include that. This is probably going to be brand new for most people. The two things I want you to remember about increasing and decreasing is please start by putting parentheses. We always use parentheses for increasing and decreasing, and we always describe them in terms of x values. So if you were looking at this graph, and let's pretend that you were running, how would we describe this? Well, from left to right, this part you would be running uphill, so let's write INC for increasing. This is where you get to take a little rest, and then as soon as you move past negative 1 and you keep moving to the right, you'd be decreasing. Now, we're able to use those terms increasing, decreasing, and resting because we're describing the y's. The y values, the rate of change in the y's is what describes increasing. The rate of change in the y's is what describes the decreasing. So let's come over here. When I put in values, I analyze it by writing in the x value. So here is increasing. How do we do that? Well, as it comes from the far left, it will continue to be increasing all the way up till when it rests. What x value does it decide to take a rest at? What x value? Negative 1. And now this is really confusing for students. Remember, I'm using x values to describe where it decreases. After I leave an x value of negative 1, it begins to decrease. And as I move to the right, it continues to decrease. Here's where I'm saying it decreases. Now, how do I describe as I continue to move to the right? Continuing to move to the right is positive infinity. It will decrease after it leaves an x value of negative 1, and as it moves to the right, it will continue to decrease. Let's go to the end behavior. Please do not fill in the boxes yet. Let's just put this general formula down. I should really say general notation. End behavior is always describing the far left and the far right x-axis. So I'm going to go to the x-axis, and I'm going to start on the far left. If this is brand new to you, this means far left. This means far right. So I'm going to make this elongated circle or oval on the far left, right in here. Okay. And this oval could go down as far as we want it to, okay? But it's on the far left. Now, as I enter into this oval shape, which direction is my function headed? Anybody, tell me. It's decreasing or going down. What symbol do I write? Instead of writing down, what symbol do I use to describe going down? Minus infinity, negative infinity. And now this part says as I go to the far right on the x-axis. So make yourself another oval here. Now, is it possible for you to be able to do this without drawing an oval? Yeah, this is just a helpful thing for people who have never seen this. Now, as I go and enter into this oval, because remember it can extend down, which direction again am I headed? Down, or decreasing. So I'm going to put a negative infinity into that. For this particular problem, once again, we have no x-intercept. So I can write does not exist. Please do not put a 0. That would mean that the x-intercept is at 0. Or an option would for you to make these curly brackets with nothing inside. The y-intercept here occurs at -4. We're going to write it as a correct ordered pair. And without me giving you an equation, how do I know what the leading coefficient is going to be? It's going to be negative. And the reason for that is because my shape opens downward. To our next example, and this is a piecewise function, so we're going to add in a few new things here. I'm going to grab a blank piece of paper, and we're going to start with the domain. So I'm going to start on the negative x's, and I'm going to move to the positive. And as I go, I'm just checking, is it continuous? Is it continuous? It's continuous from left to right. It's continuous. It's continuous. Okay, there's an open circle, but there's a closed circle down below. So it's continuous, it's continuous, it's continuous. There's a closed circle, there's an open, so not only it's a function, but it's continuous. The entire way it's continuous. So for the domain, it's going to be negative infinity to positive with parentheses on either side of the infinity symbols. I'm going to press pause, and I'm going to give you 10. So I'm checking is it continuous not with the x's, but I'm looking at the y's. So I'm going to start right here. So this is continuous going down. So I can see that there's no limit, although it's going on a diagonal direction, there's no limit how low it's going to go. So the range is negative infinity, and I'm going to keep going up. I'm going to keep going up. If you want to grab a blank piece of paper when you try a problem later on, that's fine. I'm going to keep going up. Oh, it's continuous here. So even though it stops here, it's continuous over here. It's continuous. Okay, it's still continuous. Okay, even though we have this flat line over here that's horizontal, it's continuous. Where does it actually stop? At what y value do I stop at? I stop at 10. And does everybody see how it's a closed dot? I need to be able to illustrate that. So it goes from negative infinity all the way up to positive 10, and then it stops. Turn to somebody next to you. What two things do I want you to take away and remember about identifying where it's increasing, decreasing, and constant? There's two things. What are those two things? You have 10 seconds, go. Always use what? Parentheses. So every one of these, put parentheses down. Always use parentheses. And then the second thing is always describe them in terms of x values. So in order for us to tell if something's increasing, decreasing, or constant, we're talking about the rate of change, right? We're looking at how the y value changes as we move across the graph from left to right. But we're going to describe it in terms of x values. So let's start with the easiest one. Constant means flat. So of these three separate pieces, the obvious one is, does everybody agree this is where it's flat? Okay. Where is it flat? This arrow means that as I move to the left, it will continuously be flat. All the way, like at a negative 100, it's still going to be flat. So This arrow means as I move to the far left, it will always be flat, and it will continuously be flat up until what x value? This x value is -3. If you feel like you understand that, put a star here. If you feel like you understand that, put a star. It's okay if you don't have a star. Okay, from left to right, this part is increasing. So this is constant. I'm abbreviating. This is decreasing. From left to right, this is increasing. So I go to the increasing, and I'm describing it in terms of x value. So at what x value? After I leave an x value of -3, it begins to increase. And it will continue to increase up to the x value of +5. If you understand that as I'm explaining that, please put a star. Decreasing. I'm going to say that like less than 50% of people will understand this part. After I leave an x value of +5, it starts to decrease. Here's where it's saying it's decreasing, right? Now, in terms of x values, where does it decrease? After I leave 5, and as I move to the right, this piece of the function is decreasing. So what symbol do I use to say I'm going to continue to move to the right? To the right is positive infinity. So where do students get confused? They want to write down a negative infinity because they're like, Miss, it's going down. Here's where it says it's going down. I just need to describe on the graph where does it go down. From 5, as you move to the right, it goes down. Really difficult. Now we are going to describe, if you could come down here, please, I want you to write this down. I want you to underline this and put where y values are positive. And this is going to be where the y values are negative. This is where the y's are positive and where the y's are negative. So here's where the confusion occurs. The y values are positive in my purple region. Can everybody look up here? This is all purple. Y's are positive. Okay, in the blue region, the y's are negative. I'll look up here. What would you say about the pink region? Are they positive or negative? Turn the person around you. This is supposed to be, by the way, purple, blue, and that's supposed to be pink. So what about the pink region on my graph? Are the y's positive or negative? Turn to somebody around you. What are they? Who says, I believe they're positive? Hands up. I believe that this region right here has positive y's. Who says they're negative? Who says they're both? Who says it's a neutral region? Neutral. It's neutral. So this part right here is neutral. It's neither positive nor negative. When you're at 0 and you think about a number line has negatives to the left of 0, it has positives to the right of 0, but at 0, it's neutral. And that plays a factor over here. So when I'm asked to find, hey, on this graph, where are the y's positive? Okay, that's in my purple region. So I'm going to come up here, and I'm going to grab this crayon, and this is the part right here. This part right here is going to be positive. This part right here is going to be positive. And now I need to describe that in terms of x values. This is x values. So we're going to get started. You ready? This part in terms of x values. This arrow says there's no limit how far it goes to the left. So there's no limit how far it goes to the left, and it goes all the way to an x value of -3. Now my question for you is, at -3 with an open circle, at this point, there's an open circle. Does that mean there's actual point there? If there's an open circle, there's no point, right? It doesn't exist. So I need to put a parenthesis. If it was closed circle, I would make it a bracket. So I've taken care of describing that part being in the positive y region. Now this portion, it starts at a y value of 0, but we just spoke about how at this point you're neutral because you're on the y-axis, or the x-axis, excuse me. So you're neutral on the x-axis, and this part of the function all the way up to an x value of 5 will be positive. Now, when you get to an x value of 5, notice how there's a closed dot. So I need to put a bracket. Really difficult stuff. Turn to 1 to 2 people around you. Why does the 0 have a parenthesis but the 5 gets a bracket when you're describing where y values are positive? Once again, why does the 0 get a parenthesis and the 5 gets a bracket? Turn to people around you. 10 seconds, go. And the reason is because when x equals 0, you would be actually right on the x-axis. The x-axis has a y value of 0. It's neutral. That's why it's not positive. It's neutral. But x equals 5 is in the y positive range. I need to include it. Let's go down here to the negatives. So this region is very similar to this. We're starting at an x value of -3. Now, I see a closed dot here. So will I put a parenthesis or a bracket? Turn to your partner. I see a closed dot here. Do I put a parenthesis or a bracket? It's a bracket. Learning that is difficult and it takes time. It definitely takes time. Now we're going to follow this along the function all the way up to an x value of 0. But when you get to an x value of 0, you're right on the x-axis. It's neutral. It's neither positive or negative. Let's do this part. This part is in where the y values are negative. So we're starting at an x value of 5. Will 5 have a parenthesis or a bracket? Turn to somebody around you. Notice it's an open circle. It's a parenthesis. Why is that? It's an open circle. We can't include it. And as I move to the right, it will continually be negative. As I move to the right, it's very, very common for students to want to put a negative parenthesis, a negative symbol here because they say it's going down. But remember, we're describing this in terms of x values. Now, this part is pretty easy if you can just look at your graph. So if you look at your graph, let's go through this. This provides us with x values, and we want to know what is the corresponding y value. So let's estimate where we can find x equals -13. That would be way out here, x equals -13. Well, if I extend this graph, what would be the corresponding y value? What would be the corresponding y value when you find an x value of -13? It would be a y value of 2. So please put a 2 here. Let's find f of -5. That means go to on the x-axis to -5. All right, I'm right here. What's the corresponding y value? It is 2 again. Let's go to x of 2. X of 2. Okay. X of 2 is right here. I know you can't see yours very well, so let's look up at mine. Right here it is. So when you're at x of 2, what is the corresponding y value? It is 4. Now here's the tricky part. Remember, this is an open circle and this is a closed circle. So f of 5, I'm going to go to f of 5. Would I go up to 10 or down to -5? Turn to your partner. Which one would I consider? Which one? It's only the closed dot. So I go up, and the corresponding y value is 10. We are almost done. Hang tight. Please follow along by making the correct notation. This means I'm going to go on the x-axis. When we describe end behavior, we're going to the end of the x-axis, the far left and the far right. And we're just going to describe what's happening. We always will have one of 3 answers. It could be going up, it could be going down, or maybe it's flat at one value. Let's take a look. Let's go to the far left. So I'm going to make an oval shape on the far left. And as I enter into that oval shape, do you see how this time it's saying flat? What y value is it saying flat at? Look at your paper. What y value is it saying flat at? 2. So this is 2. Now let's go to the x-axis on the far right. So far right. And as I enter into this oval, this time it's headed down. What symbol means it's going down? Minus infinity. Now, this particular function does have an x-axis and a y-axis, and oddly enough, it happens to be the same. We cross the x-axis at 0 and the y-axis at 0. So both of these happen to have 0, 0 for the x and the y-intercept.